I messed this up. But anyway, if t is, I'm just double checking that I did this all right. I'm pretty sure I did though. If you plug in a number, if you take the, if t is less than ln 4, then e to the t is less than 4. And then 1 over e to the t, if e to the t is less than 4, then 1 over e to the t is bigger than a fourth. That's right. And bigger than a fourth times 4 is bigger than 1, so that's positive. Okay, so I just common sense double checked all my work. Alright, all of this is to, and I need some more space, so I'll erase this work over here where I determined the end behavior and the horizontal asymptotes and stuff. And I'll now make my sign charts. I think I have enough room for G prime and for G double prime. And what is the sign chart for G prime? I called it F over here, I meant G, of course. Well, pretty boring. Numerator always positive, e to the t is always positive, this stuff's always positive, so this is just positive always, which tells me that this function is always increasing. And finally, G double prime, this is the part that took all the time and effort. G double prime, I have determined, if you followed all of this, that 40 is always positive, e to the t is always positive, this is always positive, so the only thing changing sign is this expression, and this expression changes sign. This expression is positive if t is less than ln 4. So this is going to look like that. And what I've then therefore determined is that this function is concave up on the interval from negative infinity to ln 4, and concave down on the interval from ln 4 to infinity. And then putting this all together, I determine that the shape of my graph is increasing concave up, so concave up increasing, and concave down, concave down increasing, so concave down increasing looks like this. And so when you put all of this together, you learn that ln 4, which is, a little bit more than 1, so if that's 1 or whatever, then ln 4 is going to be over here somewhere. When I plug ln 4 into this function, here we go now, plug in ln 4, well e to the ln 4 is 4, and so that's 4. So 4 over 4 is 1, so that's 2 in the denominator, 10 in the numerator. And here we go, we have just proved that in fact, for any, well, we didn't prove it in general, but in general it would be the logic would be exactly the same, and the algebra and the calculus would be exactly the same. But for this particular logistic curve, which was basically generic as far as I'm concerned, we've proven that it is precisely at x equals ln 4 that I have a point of inflection where the concavity changes from concave up to concave down. And when you plug in ln 4, you get 5, which is half of this number, and that's not a coincidence. So what does this graph look like? It is increasing concave up, left end behavior 0, increasing concave up, behaving like an exponential function, increasing faster, 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 faster. Then this is the point at which half of the population has already caught the disease, basically, and so now the rate at which more people are catching it starts to slow down, and there are happier examples like fashion trends, or the way in which a rumor spreads, or linguistic change. There are many, many phenomena which follow these. Social scientists call these S-shaped curves. But for our purposes for this moment, this is the point ln 4 comma 5, and that is a point of inflection where the function goes from being concave up to concave down. Okay, and you will study these again in analysis 1b from a different perspective. Woo! 4 problems down, 1 to go. I knew this was going to happen. This one maybe is a little bit easier. This is the longest homework ever. If you do all of it, you should get some kind of surprise. All right, reward. 44. F of x equals 1/24th ln. 1/24th x cubed minus ln x. 1/24th x cubed minus ln x. Okay. Let's go. First of all, note that the domain of this function will certainly be only 0 to infinity, because I can't take the natural log of a negative number or 0, so that's worth mentioning. And then the other thing that's worth mentioning, and in the past some students have freaked out about this, is that if I want to know when the zeros are of this function, then I need to solve 1/24th x cubed. I need to know when does this equal ln x. And this is exactly the kind of equation that I just can't solve. So, of course, there are sort of advanced techniques for estimating this, but these kind of polynomial and algebraic and logarithmic functions sort of don't mix with each other. So there is no method, simple method, algebra method to solve this equation. So we can merely estimate it. So you are not expected in a problem like this to, if you were doing this by hand with no technology, you would not be expected to find the roots. You just can't, you can't do them. You can't do that, so I'll just write, I don't know. Since this function kind of behaves a little bit crazily when you plug in, when you take the ln of a tiny positive, I think it is worth, this is another sort of skill, is to take the limit as x approaches 0 plus of this function, because we need to know what this function is doing near 0. And okay, well, when you take the natural log of a tiny, tiny number, it's a huge negative, so this is going to go to infinity. And this is basically just 0. So this is very relevant when it comes to curve sketching, that the limit as x approaches 0 plus is going to be infinity. Okay, any other pre-calculus left? I don't think so. Let's just take the derivative of this function. What do we get? Well, we get, 1/8 x squared, and then the derivative of ln x is 1/x. So that's kind of nice. And now maybe the thing to do is to factor this. Let's see, if I take out 1/8 and also 1/x, then I'm left with x cubed minus 8. I think I did that correctly. And that's definitely worth doing, because that's going to, well, I'll just stop there. And now I'll take the second derivative. What's the second derivative? 1/8 x squared, so it's going to be 1/4 x. And the derivative of negative x to the negative 1 is just x to the negative 2. And even here, I will factor out, I'll just factor out 1/4, and I'll factor out x to the negative 2, leaving me with the x to the negative 2 times x cubed is x, and then this would be plus 4. So, what have I determined here? I've determined here in blue a formula for the first derivative that's also nicely factored to tell me when its sign is positive and negative. And for the second derivative as well, this is going to be x cubed plus 4 over 4x squared is the form that I want to have my second derivative in. And let's make the sign chart. F, I don't know how to make the sign chart for, so I won't. F prime, and I also observe that I only start counting at 0. So so this is 0. When does this change sign. So actually I don't want to do that. I don't want to do that yet. Let me just interpret my first derivative as is. What do I see about this first derivative? Well, I see two things. In the bottom is an x, so we will change sign at 0. And over here, what can I say about x cubed minus 8? Once again, this is kind of an extension of what we did in Precalc C, I suppose. You're just supposed to be smart enough to realize that when x is 2 or bigger, this is positive, and when x is less than 2, this is negative. That's just a fact. So this is going to change sign at 2. So this is basically quadratic-y. Sign change from negative to positive at 0, sign change from negative to positive at 2. So here's 0 and here's 2. And the leading coefficient's positive, so it's plus minus plus. And for the second derivative, I will also just interpret it. Notice that the bottom is always positive. What about the top? Well, the top changes sign at like cube root negative 4 or something like that, right? Okay, so if you're being kind of weird, I guess you could do this. Cube root negative 4. That's a thing, right? If you plug in a number which is less than cube root negative 4, when you cube root it, it will be less than negative 4, and when you add it to 4, it will be negative. So it's not wrong to say that this second derivative is negative to the left of negative cube root 4 and positive thereafter. But it is a silly thing to say because, and now I will remember conveniently, that the domain is from 0 to infinity. And so really the only part of this function that's worth talking about is from 0 on. And so you can just sort of now ignore everything to the left of 0, though I think that when it comes to making the sign chart, it's actually convenient to make the entire sign chart and sort of then ignore the part that's not relevant. Okay, so what do we see? We see that this function is decreasing from 0 to 2 and increasing from 2 to infinity. So there must be a relative min at x equals 2. And this function is just always concave up because for any positive x value, this second derivative will be positive. And putting this together for my shape picture, then okay, now I will only talk about it starting at 0, and I see that there are two shapes that this graph has. It's always concave up. It's first decreasing concave up and then increasing concave up. Okay, and now, finally, I will graph this. So, what do I know? Oh, also, ln grows very, very slowly. So, the limit as x goes to infinity of this function is also going to be infinity because this cubic grows way, way faster than this natural log function. So, I have infinite f behavior on the right. I have a vertical asymptote at x equals 0 because, well, we determined that near 0 this function's infinity. And the only really thing that happens is a 2. I have a relative min. Okay, here's the part you might find kind of annoying. When you plug in 2, what do you get? 2 cubed is 8, so it's a third. So f of, let's see, I'll put this over here. F of 2 is a third minus ln 2. And I'm just going to tell you that like ln 2 is bigger than a third. It just has to be because is ln 2 bigger than a third? I feel like that's just true because this is the equivalent of saying that 3 ln 2 is bigger than 1, which is the equivalent of saying that ln of 8 is bigger than 1, and ln of 8 just is bigger than 1 because 8 is bigger than e. Okay, so, wow. Is that all legit logic? I think it is. Yeah, so since 8 is, yeah. So, that means that this will be negative. I don't know what, but it's going to be some negative number. So I'm just going to put a dot here, and I'm just going to say that this function, I don't know what the roots are, but it has roots. And I don't care what they are. Okay, finally I graph. What does it look like? Oh, well, after all this, it's kind of boring. Relative min and x equals 2, concave up all the while, infinite behavior near 0, coming down for roots somewhere I don't know where, and going back up again. So that's my graph. And maybe it's not perfect, but it's correct with respect to the concavity, the fact that there's a relative min at 2 comma 1/3 minus ln2. There are some roots somewhere. It's got the right end behavior. And that's it. Okay. Woo! 5 problems took us an hour and 22 minutes. That's about what it takes. These are really, really hard. And we're not going to do any more because they take forever. Okay, goodbye if you watch this entire video. That's amazing. Goodbye.